Let's begin by defining what actually is static testing. This here on the right is the testing trophy. That's a term that's been coined by Kenzie Dodds as an alternative to the good old testing pyramid. And in the bottom we see like the foundation of it all is static testing. When we do unit tests, as Kenzie Dodds says, like write tests, not too many, mostly integration. So like the big chunk here is integration. We have a couple of unit tests, and end-to-end tests, like they give you a lot of mileage because they test the whole system. We'll look at the bottom part of the testing trophy. And what is static testing? It checks your code for defects without actually executing the app, as in the other ways of testing. And a nice thing about static testing is that it can be automated with code analysis tools. This is nice, or like there's a nice property about static testing that is like you set up your test suite once, and then you can add a new feature, you don't need to change your static tests. Whereas if you write unit tests, like each time you add a feature, you need to add a new unit test. So the other kind of testing, it's a lot of work. Static testing is for lazy people. I love it. Reviews also, like there's no code executed in reviews, or like you can, but you don't have to. But actually studies have shown that colleagues, they are way more likely to take like a pedantic feedback from a computer than from you. Like if I say like, Sebastian, like these imports, they should have been sorted alphabetically, he won't be happy about that. But if a machine tells him that, I don't think he minds, especially if it's automatically fixed. So let's jump to my piece of code. I will try to run it. It's a tiny little Flask app, and it's implementing one endpoint. How long is my name? Hey, have a seat here, get a drink. Have a little HTTP request. It just sends to this endpoint a JSON body with a name property and with my name, and I send it, and whoops, it did not work. I get a syntax error, like the interpreter didn't like my code. How can that happen? Like I have a Python app, I ran it, and it's still broken. This is a thing that can happen with Python code, and luckily we have our static tooling that can help us detect such problems. The first tool that I want to present here is Flake 8. It's maintained by the Python Code Quality Authority. That's an organization of maintainers that maintain many projects about automatic style and quality reporting. And Flake 8 is a tool that, out of the box, it combines PyCode style, which is a little checker that validates the PEP8. PEP8, that's the golden rule that dictates things such as Python code should be indented by 4 spaces. And if you write a class, you should have like 2 blank lines above and below of free space around them. That's the famous PEP8. And PyFlakes, it's a linter that finds many problems, no style problems, but like actual coding problems with your code. For example, import errors, name errors, like duplicate names. And PyFlakes, it's committed to not making many false positives. So you can run it and it will not annoy you a lot. And Flake 8 also bundles a computational cyclomatic complexity checker, so it will flag some really complicated methods. But what's the value proposition of Flake 8? Like, it ships with these 3 tools, but actually it makes adding and writing plugins easy. So you can write your own rules, you can use other plugins, and you can all run them with Flake 8. Like, it gives the infrastructure for these tools that each take a single file, and it lets you recurse through directory trees and include and exclude files. Pretty nice tool, and it's also fast. because it looks at each file in isolation. That's also something to keep in mind. Like this tool is limited by looking at one file. It cannot understand your whole program. And the largest plugin that exists for Flake 8 is the vmake Python style guide. That's a project whose mantra is strict is the new cool, and they want to make all people on this planet write the same Python code. Like they want to lint you to death that you that all Python code looks the same. It's actually quite a nice idea. Let's see what Flake 8 looks like in production. So finds lots of whitespace errors, and on the very top also a syntax error. Thank you, Flake 8. You just saved me from deploying a bug. It gave me feedback on my lengthy length computer. Apparently it's too complex. Well, I will just replace this implementation by length of the input. That should work as well. And then all the other errors, I don't really want to fix them, like white space, blanks. I don't want to fix these, so I will ignore them for now. And we'll see how we can fix them in a second. Yeah. Folgefehler happens, always hidden. Blank line at end of file. Good. Now we're good to go. Okay, so how can we fix all these whitespace errors? I really love this tool called Black. Black is a PEP 8 compliant code formatter. It's maintained by the Python Software Foundation, which means it's relevant to the Python ecosystem at large. It's gained a lot of popularity recently in the last years, and since this year it's also not in alpha state anymore. And Dusty Phillips said, Black is opinionated, so you don't have to be. This is a really good tool to use in your company because it saves you time and money. It removes the needs of lots of discussion between your developers. Like, developers love fighting about style. Like, hey, do I need to use a new line there or not? And Black is taking these discussions away from you, and all of us, we can focus on the real things. If actually that's not your deal because you really want to dictate your own style, then I can recommend Yap, which has like something like 200 config options, so you can really adjust that to your likings. Alternatively, AutoPEP 8 is also a popular choice for code formatters. And the nice property of them is the abstract syntax tree is not changed, so you can run it, and the semantics, the execution semantics of your program will not be affected. So let's run Black on our tool. And it formatted the code and looks a lot nicer already. Yeah. Hey, this actually looks like decent code. I like it. If we run Flake 8 again without the ignore, it's happy. Great. We're one step further, and let's give the program a shot again. Still not working. We used so many static linting tools, and apparently we have such a blatant error in there still. Authorize is missing one required positional argument. Like, it's just code that never would have compiled in a language that's being compiled before you deploy it. How can we find such a problem? And for this, we're going to look at a type checker. The most popular type checker that's out there is MyPy, and it'll catch such typing mistakes. It'll understand your whole program. If you import something, it can understand and check the interfaces of your code, to others of your modules, and to other dependencies that you're using. And MyPy works using the type-ins feature of Python. They have it since Python 3.5. So if you add type-ins, then MyPy can understand them, and everything that's type-inted, MyPy will warn you if it's used incorrectly. So I've actually used some type-ins in this project because I really like them. So if we use MyPy, let's see what it can tell us about the program. MyPy is not the fastest. Should have probably run that before the talk to, like, it has a cache directory. The next one will be faster. First error it found, missing positional argument, password, and call to authorize. So it actually found the problem that killed our request here. So I'll just fix that. I know I can put in a none here. Also told me that, I can quickly open that function. Oh, it's not even type-hinted, and it still found that problem. Really nice. Thank you, MyPy. Thanks for this. But it finds other problems as well. What about this one? The lengthy length computer has incompatible type int. It expected a string. Why is that? Okay, so I'm getting the JSON from the body. Then, because I don't want to work in a dict in my code, I declared a data class that I instantiate with this dict, and apparently I made a mistake here with the type int. Good. And now this data class I then use, and I pass it on to my business logic. So I run it again. One problem left. Validation. This is a Flask app, and you're passing code, you're passing data into it, and I missed a validation step. This could actually be none. So what could be none here? Value of type, main, data could be none. So I'll just do a little check here. If data is none, then return that should have contained a body. Cool. Should be fixed. And now I should be able to send requests without body as well. And it worked. Great. Jonas is 5 characters long, so the program finally executed. Now we already looked at validation here. So we checked that data is none, but what could data actually be? Many of you that have been writing code, endpoint code without fast API, they probably know that the validation can take up easily 50% of the endpoint code is just validation. And this is quite tedious. So we now know the business logic is typed correctly at the function, but the input of a program, if we take in a different input, if we take in 42 an integer and run it against the program, it will break. So we need to add a validation layer here. And who of you knows about Pydantic? And who of those that know about Pydantic love Pydantic? Ah, that's everyone. Great, yeah. I love Pydantic too, it's awesome. Pydantic is a little tool that does data parsing and validation and replaces all the manual checks that you would need to write otherwise. So we can actually integrate that quite easily in our application. I'm already using data classes to handle my data inside the application. So if I make this data class a Pydantic data class, then Pydantic, upon instantiation of this data class, will check, is name a string? And if not, raise a validation error. Actually, it will try coercion because it's not like if I pass this here, it will interpret the 42 as a 2-character string, but I can also force it to raise the validation error. So I can say from Pydantic import strict string, and I can type the name as strict string. And now if I run this again, I get a validation error. Like I can catch this, I can raise an error response, a 422 error, and tell the user of this API, hey, please pass a string the next time, try again later. So this has been MyPy and Pydantic, and in the typing universe in Python there's actually lots of type checker alternatives. Writing a type checker is not easy, and you might want to ask, why did Microsoft, Facebook and Google do it? Maybe because they had lots of infrastructure in place already and they thought like, okay, we can adapt this to Python. And they did. MyPy is still the most popular one on GitHub. Pyrite is the one that's being used in the VS Code. PyroShack, probably used by Instagram. And PyType takes, as far as I know, takes quite a different approach. Like, I think it can even detect typing mistakes without you adding the type hints in the code. And some of them, I didn't test it, but they could perform faster than MyPy. That's a common argument, that MyPy is a little bit slow in a large code base. Yeah, PyCharm also, another one, implements their own proprietary type checker. There's more static code analysis tools, and there's a lot more. And this is the last one that I want to go into in detail. It's called Bandit, also maintained by the PySecure, and it'll find some common security issues for you. That's really handy. Like it'll find wrong usage of popular libraries, like if you're using Flask wrong, it will tell you some instances. It will tell you if you use a weak crypto algorithm, which you shouldn't use. Maybe you studied like too long ago and forgot, like still using the crypto algorithms from back then. And if you by accident commit a hard-coded password, that probably happened to everyone, that they did a Git tree search through the history and force pushed on a GitHub repository to remove that password again, right? Or is it just me? It's just me, is it? Let's run Bandit and see what it will find. So it found some problems. What did we do? A Flask app appears to be run with a debug true mode. I forgot to remove that debug flag before building the container and pushing it to production. That could have ended bad. Really nice that they told me so. What else did I do wrong? I used an assertion. Hey, I thought I could do that. I thought I could write code like this. But apparently the Python compiler can optimize away asserts, so it should never be used in business logic. Good to know. Want to do it again? And yeah, that's probably what the import os code was for. I probably wanted to import that from an environment variable. But I skipped this step and I forgot to undo it. Thanks for letting me know all these things, Bandit. That was a lifesaver. Other tools include, not exclusively, iSort, sorts the imports for you. I actually never gave review feedback that things should be imported differently, but still after using iSort, the code looks a lot cleaner, the imports. Pyland, it's like Flake 8, but it doesn't look at single files in isolation, but it can consider dependencies and types as well, so it's able to catch a lot more errors. And it might also come up with some false positives. So you might need to do some configuring when you roll that out in your project. Then there's something called pre-commit hooks, which is a collection of handy checks like, is my JSON formatted right, or my YAML? I don't know, probably like, do I have a to-do comment in there? Like there's really a ton of small, useful little checks. Trivia is a vulnerability scanner that checks your Python dependencies. License Finder checks your Python dependencies, and depending on a whitelist or a blacklist, it'll tell you if you should have used this Python. You should always use Python. If you should have used this license, except for performance relevant code, when maybe you need to use Python or C++. For most parts of your code, you should use Python. SamGrep has a lot of bug checkers. It comes with a little language where you can write your own your own rules, and you can enforce like coding standards or patterns that you tend to use. And for example, in your endpoint, did you check that the user is authorized? And of course, SonarQube and CodeClimate, the giants out there, like their code analysis suits, they have a lot of rules, and they focus on dashboards and showing you the results nicely. And do I need to run every time I commit each of these checks? So I'm running like 10 scripts each time? No, you don't need to do that. There's a really cool tool that's called pre-commit. It's by Anthony Sottili, who is also the maintainer behind Flake 8. And it's a tool to manage Git hooks. A Git hook is a custom script that's automatically executed in the life cycle, in the Git process. Like you can have a pre-commit hook, you can have a pre-push hook, and we like to use it as a pre-commit hook. And we can configure it so it can run all the tools that we use ahead of every commit. And the main selling point of pre-commit actually is like it makes the installations of these tools really simple. Like it creates an isolated environment, for example, to install plugin, or if you're using JavaScript, to install Prettier in. And if you don't have JavaScript or Python installed on your system, whatever system it is, Windows, Mac, it will even install Node for you, and then install an environment and install the tool in this environment, and then run this check. This is not only useful for Python. It's written in Python though. Let me show you what that looks like in the code. So I wrote a little pre-commit configuration here. We're running Black, Flake 8, MyPy, and Bandit. And now I made a couple of code changes. Now let me see if this tool lets me commit it. I click commit. And it's running the hooks, and it gives me a little warning message down here in the corner. It said, my main function is also too complex. Still have some typing problems, probably because I switched out the data class with a pedantic data class. And of course, all the bandit problems that I didn't fix yet, it tells me about them. So it does not let me commit and keeps my branch clean. This was a lot of tools, and these tools, they produce a lot of errors as well. You haven't set them up from the beginning of your project, so how do you get started? It's a good idea to start with a few files or directories only and exclude the messy parts of your code. Then many of these tools, they can be configured to be more relaxed, like to only run a subset of their checks. And it's always good to add them together with an autofixer. That's the best. For example, Black auto fixes your PEP8 mistakes, or AutoFlake 8 fixes anything that Flake 8 finds. And it might also be handy if you can create a baseline, like you can say, oh, this is all the errors that my code has right now, and I only want to be notified about new errors that I make. For example, Flake Hell is a tool that can create such a baseline, and then you can run your checks against this baseline. It's really handy. Yeah. This has been my introduction in static code analysis with Python, and feel free to ask questions now. Thanks for listening.